Good morning, people. My name's Vern Pitt. I'm a senior reporter here at Building. Here to welcome you to today's webinar, Part L, Zero Carbon Ambition versus Reality, brought to you with the help of our sponsors, Knauf Insulation. We've got a great lineup of speakers here for you today. First up, we're going to hear from Richard Stockholm, Operations Manager at NHBC. Then we're going to hear from Stephen Wise, Technical Director and Manager at Knauf Insulation. Then we're going to hear from Tassos, Technical Manager at the Zero Carbon Hub. And following that, we'll hear from Kirk Archibald, Associate Director at PRP Environment. During the presentations, you are able to ask questions at any time. We'll be addressing those in the sort of last 15 minutes of the session. There is a ask a question box below the slide presentation. Just type your questions in there. We'll be picking those up later. Also, should you wish to do so, you can ask your questions or interact with our speakers on Twitter. There's a hashtag for this webinar, hashtag #PartLFuture. So if you just tweet using that, we'll be trying to pick up some of those as well as we go along. Finally, there will be a series of poll questions throughout the webinar, which we'll be giving you the answers to just as they come through. And if we have a chance, we may try and pick up some of the issues raised by those towards the end of the session. So that's enough from me for a brief introduction. If we can get on to our first speaker, Richard from NHBC, who's going to give you an overview of the changes to Part L in 2014. Richard, over to you.
Yes, thank you very much, Vern. Yes, so what I'm going to do before we hear from the other speakers is just go over the headline changes, the key points that should concern you with the new Part L 2013, go into a little bit more detail about some of those headline changes, some of the new things that you need to concentrate on, and also the main 5 criteria for compliance. They are still very similar, but there have been a few changes that you do need to be aware of. So, first of all, we've got the 6% uplift on Part L 2010. Now, the thing to remember with that is that it's not a straight 6% on every single dwelling. It's across the entire build mix, so what that means is some properties you'll find will actually be performing greater than 6%, obviously depending on the particular type, such as a detached house may find it has to perform slightly better than the 6%, and then some of the other properties that used to have more of a problem in terms of getting an increase over the 2010 regs, such as mid-floor apartments, may not have as much of an uplift as 6%. But overall, when you look at the build mix across the UK, you'll end up with a 6% uplift on aggregate. We've maintained the fuel factors, and one of the key things in 2013 is that we have a new mandatory requirement for fabric energy efficiency standards, and I will go into that in a little bit more detail in a minute. However, one of the other key changes, in 2010 you did have to provide information such as commissioning certificates to the homeowner. Now there's a more requirement on the handover information to the homeowner, more detail, how you've actually chosen to comply with the requirements, and obviously you do need to consider how you're going to get that to the homeowner in a sufficient form. With the new recipe, there is a recipe approach, and obviously one of the things you do need to consider here is that we have stopped what we started in 2006, where we had a percentage improvement over a notional dwelling. Then for 2010 we had a 25% improvement over that. So we were having improvements over improvements, which meant that we did have some fairly strange results where the same fabric specification would have a very different result depending on the type of property that you're applying that specification to. With the new notional dwelling setup, you're actually comparing your actual dwelling to a notional dwelling that is the same size, same dimensions, but has this new fabric spec applied to it. and that does even the playing field. So you can basically use the same specification and you should see very similar results across the board on your house types. So we've introduced the fabric energy efficiency standards into the 2013 regulations, first introduced by the Zero Carbon Hub as part of their minimum fabric requirements. The easiest way to think of this is it's the stuff that you can't really take out of the house. So it's the fabric, the thermal bridging, the air permeability. Things like low or zero carbon technologies don't affect the fabric energy efficient performance. And that's really important to note that once you started building your property, fabric energy efficiency, you're pretty much there. You can't have any bolt-ons later on that are going to help you achieve your target fabric energy efficiency. So really important to get your fabric energy efficiency sorted before you start on site. In terms of the 5 criteria for compliance, we still have what looks to be a very similar set of requirements. Number 1, achieving the target emission rate. See, now there is the target fabric energy efficiency, which is created from that recipe, which I will show you in a second. The limits on design flexibility, those backstops, those area weighted average U values are still there. So the wall average U value of 0.3 is still there. They haven't reduced those. Limiting the effects of heat gains in summer. Now that's changed slightly from solar gains, so that means you do have to consider heat gains from pipe work, so uninsulated pipe work that's carrying hot water. You do have to consider heat gains for that as well. Obviously, we also have the building performance consistent with the DER, and that kind of, and the design target fee, that falls in with the zero carbon performance gap work. It's kind of a leader into that of making sure that we are building what we said we were going to build at design stage. And then number 5, it's the provision of the energy efficient information of the dwelling. Again, some kind of home user guide to provide the building owner with how to use the services that you've installed. So if we take a quick look at the recipe, and I know obviously presenters after me are going to go into a little bit more detail on this, but effectively there is now a recipe for Part L 2013 that if you build to it, you will comply with both the target emission rate and the target fee. You will actually slightly overperform for the target fee because there's a relaxation. So if you build this recipe, you're guaranteed to meet the target emission rate. However, you can build slightly lower specification in this recipe and still meet the target fee. However, it does seem that it's quite a simple thing. You just build to these U values. You do need to bear in mind that there are some very strict thermal bridging values, the psi values in Appendix R, that's used to work out your thermal bridging value, that if you can't adhere to those, you are going to have to do something else. So if you build exactly to that recipe with your walls and your windows, but your thermal bridging is bad, you are going to really struggle to comply with both your target emission rate and your target fee. So just to finish, I just want to talk a little bit about thermal bridging. Again, I'm sure the presenters after me will talk a little bit more detail, but just to go with the detail of where we are and why thermal bridging has become so important. You can see there the house on the left has got the default Y value, so that's kind of where we were when we were looking at SAP 2002. The Y value of 0.15, default value, that effectively, if you look at that as a hole in the wall, that is basically a hole in the wall equivalent to a double garage door. So think that that's how much heat you're going to lose through default Y values. That's why it's really important. Secondly, Y value of 0.08, that's accredited details. We are basically getting down to an open patio door, and that's where we've been for a while in the industry. But now looking at Appendix R values, we are actually closer to a Y value of 0.03 with all the Appendix R psi values. That's taking that opening, that hole in the wall, down to a small open window about 1.25 meters squared. So the challenge for you, and that's why it's really important, is to get that garage door down to that small window opening. And if you can't do that, then obviously you're going to have to do a lot of other things to get you down to your target emission rate and target fee. That's it from me. I'm going to hand back over to Vern now, who I think has got a poll question about the changes to Part L. Thank you very much.
Thanks, Richard. So we've got our first poll question coming up. Just before we get on to that, I just wanted to clarify, because we've had a couple of questions come in asking whether these slides would be available afterwards. If some of you were also wondering about that, they will be available at the same address from tomorrow morning. Now on to our first poll question. Do you think the new Part L changes go far enough? Straightforward yes or no there. I'll just give you a couple of seconds to answer that, and then we'll take a look at the results. There you go. Well, reasonably even split, but just over half of you, 57% there, think that yes they do. 44% think they don't. So, well, regardless of whether they go far enough, they're going to need to be met, and that's what our next speaker, Stephen Wise, is going to talk us through now with some solutions and technical information. Over to you, Stephen. Cheers.
Thanks very much, Vern. Yes, my name's Stephen Wise. I work for Knauf Insulation, and looking at research and development and regulatory affairs. So if we can move on to the next. So just in case anybody doesn't know who we are, we're a manufacturer of three basic types of insulation product: glass mineral wool, rock mineral wool, and extruded polystyrene. And all these products are manufactured in the UK at the locations shown on the map. So we are a UK insulation manufacturer. What we've done is I'm focusing largely on the TFEE element rather than the full SAP compliance in this discussion, because that's the bit that really interests us and that we can have a major impact on. That said, of course, the DER compliance is required. So this is the recipe that Richard described for calculating your target fabric energy efficiency, and we have done quite a bit of modelling to work out where what our solutions would be in terms of U value. In the current version of Part L 2013, there is a 15% relaxation of the TFEE, and we anticipate that a large number of builders are going to seek to bridge the step to achieving the full TFEE by taking advantage of some or all of that 15% relaxation in TFEE. And we have modelled to DER taking advantage of that, and for a semi-detached property we've come out with this recipe of U values. That, of course, the numbers in there can change, and you could have a lower wall U value and a higher roof U value and still comply. It's dependent on built form, and it would also be dependent on issues like thermal bridging and also thermal mass parameter as well, which is something I'll talk about at a later stage. What we've also done is modelled what U values you would need to achieve the TFEE if you didn't want to slavishly follow the recipe. And again, we've got some flexibility there. Again, by utilising choosing options that give a better result in SAP with regards to thermal mass parameter, and also by having better thermal bridging details, we're able to find some options where it's possible to have a higher U value than is in the recipe. So moving on from there, focusing primarily on masonry walls as a starter, our solution for the 15% relaxation are just meeting the the DER target, we feel comfortable that with aircrete masonry it's possible to achieve that still in a 100mm cavity with the buildings that we've modelled, and this works for detached, semi-detached and mid-terrace properties. If you aren't able to use aircrete blocks and you wish to use a lightweight aggregate block, then you have to increase the cavity width to 125mm. If you are looking to achieve a full TFEE rather than the 15% reduction, we modelled that can be achieved with a U value of 0.2 in the wall rather than 0.18, and that can be achieved in a 150mm cavity with virtually all types of block. So we think that these solutions with our Drytherm 34 or Superfill 34 products, both blown or built in, offer very competitive solutions for these applications. Moving swiftly on to party walls, this is an area very close to my heart that I spent a lot of time working on the development of solutions for this, and also researching involved in the basic research that identified these solutions. We've got fully compliant solutions with robust details for both built-in and blown insulation. For lofts, we are targeting U values of 0.11 in the loft. This is leading to 400mm if you use the current loft roll, main widely used loft roll product, loft roll 44. With a slightly improved product, you we can get to a lower U value of 0.1 with 400mm. For floors, this is a slightly difficult area for us because we manufacture undoubtedly the best type of product for general flooring, being an extruded polystyrene, in that it has the best strength characteristics and moisture absorption characteristics, but it doesn't have a particularly competitive thermal conductivity. So we are at high thicknesses of extruded polystyrene for this application, but we think that with proper engineering it would be possible, taking into consideration compressive creep and the characteristics of the product, it would be possible to reduce thicknesses of slabs and screeds if a structural engineer was examining these solutions properly. With thermal bridging, everybody's going to spend a lot of time talking about thermal bridging. It's absolutely critical because it's possible to leave a lot of performance on the table if you don't attend to your thermal bridging correctly. We have our own in-house qualified modelers for thermal bridging, and all of our modelling includes the best thermal bridging that we possibly can do, but we have made judgments about buildability in our details as well, because we're thoroughly conscious that people have to be able to deliver these details in real circumstances, and there's little point in having a fantasy detail that performs far worse than the calculation. Thermal mass parameter is interesting because it does make quite a significant difference, and generally the SAP program rewards low thermal mass. I guess it's anticipating that quicker heating from startup and less thermal lag is going to drive higher, reduced thermal reduced energy consumption. So so lightweight constructions are rewarded for thermal mass parameter. So returning to our recipe, this is these are the numbers that we've come to develop the solutions, and we have a wide range of services available to specifiers. And importantly to note that all our calculations are issued under a certification competency scheme that's run by the BBA. So that's the end of my presentation. Thank you very much, and I'll hand back to Vern.
Thanks for that, Stephen. Without further ado, we're going to get on to our next poll question. So let's get that up on the screen. Yes. So what's more important when considering new specifications? Is it cost, buildability, or energy efficiency? Please give us your answers now. Okay, let's see the results of that. Seems to be a toss-up between buildability with 38% and energy efficiency with 36%. Very interesting. Okay, well, passing over now to our next speaker, we've got Tassos from the Zero Carbon Hub, who's going to talk about proving that what you build really does comply with the Part L 2013. Over to you, Tassos.
Yes, Ben. Good morning, everyone. Thank you very much for the introduction. So I'm going to touch on the topic of the performance gap and how it relates to the new Part L and the Part L to come. Before we start, a few words about the Hub for those who haven't heard of the Hub before. The Hub is the leading organization paving the way to zero carbon houses for England from 2016. We work very closely with the government and the industry, disseminating relevant information and trying to clear any obstacles that you can find in the way. Now, at the moment, we're mainly focusing in new homes. And speaking of zero carbon homes, I hope you're quite familiar with this pyramid. This schematic indicates, this shows how an approach to zero carbon home can be achieved. It's a three-tier approach. At the very bottom is the fabric energy efficiency, as was described before by Richard, which means that you have to have a very efficient thermal envelope that will meet specific requirements. And according to the proposed definition as it was developed by the Hub, there is a maximum energy demand based on the different housing typologies that you have to achieve, which is quite fixed, and it's slightly different than the target of fabric energy efficiency introduced in the new Part L. And as a second step, there is also a specific level of performance when it comes to carbon emissions and how much carbon you are allowed to emit from this property. Again, based on different housing typologies, these figures were calculated by the Hub. And this is another way to verify that you have achieved specific levels of performance on site before you move to the third step, which can be described in general as a financial way of offsetting carbon off-site through, for example, investing on carbon reduction projects and then allocating this carbon reduction to your project. It is very important to say here that in order to access this third element of the definition, first of all, you have to achieve on-site specific level of carbon performance. So, moving on, some of the highlights that we have been discussing before when it comes to Part L 2013, we have seen a 6% overall aggregate improvement when it comes to carbon emission targets compared to 2010 regulations. And the other important element is that we have seen a reference to the fabric energy efficiency performance, which has been introduced in the form of the target for fabric energy efficiency. This is slightly different from the fabric energy efficiency standard because this is not an absolute figure. It relates to shape, form, and comes from the concurrent notional building, and this is how you compare, but we are very happy to see that there is a way to actually evaluate the performance of fabric in these new regulations. Historically, the improvements in the different versions of the building regulations and the actual target for 2016, you can see that we have done a lot of progress since 2002 with various improvements over the previous versions of the regulations when it comes to carbon. And of course, the 2016 target remains that we will have to achieve zero carbon emissions from regulated energy use and only. So as you can see from this graph, we are almost half the way there, but we have to highlight here that all these changes that they come to the different building regulations, they focus on fabric. And as I explained before on our pyramid, you can see that you can actually minimize carbon emissions through other measures, for example, on-site low and zero energy technologies or renewables. So we're not as far as you may think we are, but we still have some ground to cover before we achieve this target. So coming back to the previous topic about the performance gap, in our journey to zero carbon, we have been focusing on the different elements of the definition, and it was picked up in 2011 from our task group committee working on the carbon compliance levels that there is a risk hidden in the future. And the risk is that what we actually build doesn't perform as well as it was designed to perform. So these were the reports that this was mentioned, and the recommendation at that point was that from 2020 and onwards, the test result distribution should demonstrate that at least 90% of all dwellings would meet or perform better than the designed energy carbon performance. This is really crucial and very important because no matter how the building regulations change, if we are unable to achieve these carbon savings on site in the real world, all these carbon savings will remain on paper, which is not making a big difference, and this is not the intent. So what do we think when we listen to this word, the performance gap? How do we know that there is a performance gap? Usually after the construction has been finished, we can run some tests, and then we can see that, for example, the performance is not the one indicated in the design. And this creates this confusion around where this performance gap occurs. And a lot of people would say, oh yes, something went really wrong during the construction stage. But to be fair, there is a bigger knowledge gap that spans out throughout the building process, and this is what we really want to focus on through our work, because all the different stakeholders involved and all the different players, they can create these small shortfalls that if you add them up will create a bigger gap. So for that reason, and trying to move things forward, in January 2013, the hub, with the support from the industry and the government, started this performance gap project to identify and understand where these gaps occur and what are the risks for the future. So in July 2013, and after we have worked with more than 140 individuals in different working groups, and we had the support from more than 90 companies and the government, we started brainstorming and holding different workshops, and we produced the first report with the initial findings and the initial thinking of where these shortfalls may occur. And furthermore, very recently, in March 2014, after collecting and concentrating evidence through literature reviews, site visits, and other information streams, we produced another report that is well evidenced, and you can see the different issues reported across the building process and maybe some potential solutions and guidance. And we expect a third report this summer that will focus even more on the different aspects of the issues. There will be some extra site testing being performed. We'll look at different processes of delivery, large and small builders, and probably some sub-sensitivity analysis. So these are the two reports that we have published so far, and they're both downloadable and free of charge from our website. Please log in and download these reports. They're very useful items to have. The first one, the initial findings, where you identify and understand where these areas of shortfall, where the shortfalls occur in which areas, and the second report that is evidence. And I'm going to explain a little bit more about some features of these reports that are quite interesting. So in the second report, you'll see this prioritization matrix, when we collect all the issues and the different problems, we thought that we should have a way to classify them and understand their impact and importance. So based on the amount of evidence we have collected on specific issues and the expected impact on the performance of the property, you can see that if we had a lot of evidence, for example, and the impact was expected to be high, this issue would have been categorized as a priority for action, while if we had high expected impact but less evidence, this issue would have been an issue that would have been categorized as priority for research. So the second report with the evidence, we came down to 15 identifying issues that, as I said before, they span out from even the early stages of concept and design down to the verification and testing, and not only to the building stage, to the construction stage, and these are the priority for action. They are discussed in the report, and there are specific information and details in regards to these items. And 17 items on that identified issues that they were identified as priority for research. The 15 previous issues made the development of comprehensive solutions in the near future that can be led by the industry, or can be, if necessary, include government intervention. The other 17, the one we see at the moment, relate to lack of knowledge and usually within the testing and verification area. So, closing this brief on the performance gap, I just include the design detail that we have noticed in one of the site visits. Is not one of the most important issues, but I think it highlights very well how things can go wrong. For example, from a designer perspective, this is a detail that he will design, maybe because of planning requirements, maybe because it's from aesthetic, for aesthetics, but it's a hard detail to construct on site. Consequently, the sub-assessor may miss, for example, some of the thermal bridges, and if there is with the building control also visiting the site, again, the visibility, how much visibility they have over this junction, some things may be missed, and again, all of these will contribute to this performance gap. So I think this is about it, and I just want to advise you again to log on our website, download these reports. They are very useful for Part L 2013 and the future versions, because we have to verify that the product that we develop is actually performing as well as it should. So back to you then. Thank you.
Thanks for that, Tassos. I myself have had a look through that interim before now, and I can recommend it as being highly informative. On to our last poll question of the day. If you could tell us, do you think the UK will start building zero-carbon homes by 2016? Yes or no? I know some of you have already been thinking about this, because we've had some questions come in. Be interested to see what the result of that one is. An overwhelming vote of no there. 84% of you don't think that's going to be achieved. Well, that's interesting. Maybe we'll try and pick that up a bit later. For now, I'm going to hand over to our next presenter, Kirk from PRP Architects, who's promised us that he's going to have some pretty pictures in his slides. Over to you, Kirk.
Thanks, Anne. Very quick word in response to that question. The policy actually states from 2016. It recognises there is always a lag behind when regulation is introduced, so it's to be expected, I suppose. But nevertheless, I guess we're behind the curve in some ways. Just a quick word about who I am and where I come from. PRP Environmental is a specialist multidisciplinary team of about 15. Operates within the wider practice, made up of architects, engineers, economists, and sustainability experts, I suppose. Covers a broad church of disciplines and experience, ranging from the usual environmental services right through to some of the more specialist services that we're now delivering for some pioneering clients. I'm going to talk a bit more, I guess, about the design implications of what all this means. Before I get into some of that, I think it's worth having a bit of a cast forward to understand the context of where we're going to. You've heard a bit about the zero carbon policy from Tassos, a reminder of this triangle that was created 4 or 5 years ago when they came up with this policy. The implication of that is that we will certainly have other low carbon technologies on virtually every new house that is constructed to satisfy that policy requirement. There is also something under the European Buildings Performance Directive where you are now, well, all member states will be required to construct near zero energy buildings. And the question there is whether those two are compatible. They do ask for slightly different things. One is obviously related to carbon, the other related to energy or kilowatt hours of energy used. And there are specific stipulations, certainly within the European one, about having connections to renewable sources of energy local to the site and so on and so forth. How that squares with proposals for an offset mechanism is yet to be fully ironed out. So it's a question I'm going to leave hanging there, really. But the thought to kind of keep in your head is that we are going to build something very well first, and I'll come on to what that might mean, and then we're going to have to stick a load of other technologies into and onto these buildings to satisfy these two policy requirements. So let's have a think about form and function, I suppose, from a designer's perspective. You've heard a lot about the importance of thermal bridging now, and this is now emphasized through the compliance regime. And in simple terms, what does this mean for the designer, starting with a blank sheet of paper on a new scheme in London or wherever it might be for that matter? And I've got a few bullet points here, really. I'm just going to run through a few of them. Key, I guess, in your mind should be the ratio of exposed area to floor area. And so if you have complex shapes, or you have lots of abutments, or you have integral garages or a bungalow, for example, it's all going to get harder. Large windows, which we're all very fond of now, since we all like daylight, are going to make it harder. Higher ceilings will make it harder. So all of these things now need to be factored into your decision-making process. And even better would be to try and model some of this early doors so that you've got an understanding of the impacts of those and the scale of impact of some of those issues. There will be a huge emphasis on measuring those thermal bridging details, and indeed those developers with the funds to do so will probably value engineer this to the nth degree such that they do exploit the opportunity that the 15% comfort factor allows at this point in time. But inevitably that will be squeezed, one assumes, going forward. A couple of other points. Balconies, we're all under pressure to provide external space for people. Thermal breaks on balconies, particularly cantilevered, are an essential. If you can avoid it by having structurally independent balconies, even better. Other issues, things like dormers, they're notoriously difficult to insulate well. There's a lot of thermal bridging with all the timber involved in them. And they effectively provide a heat sink out of the envelope. The key one is probably parapet roofs. We've spent a long time trying to design these out. We're starting to see much more of these coming in, particularly with a lot of flat roof construction to meet sort of density targets, and they can be difficult to achieve because the site values are quite high. What does that mean in terms of design impacts? Well, you'll start to see drawings getting produced by architectural practices which look at these details now and really explode them out so that people are aware exactly what's involved. And this is the kind of example, if you like, on a scheme that we're working on ourselves for the London Legacy site, where they've adopted the previous incarnation of the fabric target, full fees, which is a harder target to achieve. It's an absolute target. So we've gone into a lot of detail in terms of modelling those unit types. Here's an example of a terrace from that scheme. You can see it's pretty plain looking, if you like, in terms of shape and geometry, albeit there's one or two abutments, obviously. But you can average that terrace across the length of it, and that allows us partly to get over the line in this case. But is that an indication of the shape of things to come? Here's another example of a project we were involved in, which was known locally as the £100 house project, where the target was to try and design a house with a space heating bill of only £100 a year. It's being monitored at the moment by, I think, Aberdeen University, and you can see here the sort of fairly boxy, plain-looking shape of these buildings, which went a long way to try and satisfy that ambition. I think it's also worth perhaps considering what Passive House drives you towards as a possible proxy for achieving these high standards in the future. Indeed, there is an argument to suggest that anyone certifying to passive house standards should be allowed to comply by default, and there's probably a good argument for that. But the question here is which of these are passive house? You would probably say those on the left with a fairly straightforward shape and geometry are passive house. In fact, all of them are passive house certified. So it does show that you can achieve these very high standards with some interesting shapes and designs, albeit I would argue you would have to work much harder on those on the right to achieve these targets. It's also worth probably considering alternative forms of construction. This country is pretty wedded to cavity wall construction using masonry, but this may be the time when this driver in particular starts to create a demand for alternative techniques. The one on the left is a light gauge steel system that Rockshell have developed, designed to achieve a sort of passive standard. The one on the right is a thermal box system that is largely used on the continent. It's inherently low in terms of thermal bridging, pretty good insulation levels too, and you can also add further insulation on the outside of that, which to my mind is a better way of doing things. And then there are other systems that you might want to look at too, things like ICF, insulated concrete formwork, a bit like building with Lego in my mind, but again, very low thermal bridging, and actually once you crack this, got your guys on site to understand it, it's a pretty simple way of constructing. The other is obviously some form of timber frame. This is a structurally insulated panel, again, low thermal bridging. So moving on, it's worth thinking that isn't the end of the story. We've got to start plugging in all sorts of technologies, and at the moment the technology of choice is solar PV in particular, partly because the price reductions continue to happen, and it's likely to hit grid parity, as they call it, probably within the next 5 years, possibly sooner. That is, it'll be cheaper to generate your own electricity using PV than to buy it from the grid. That's what that means. But arguably what we're seeing at the moment is what you see on the left, a fairly ugly eyesore in terms of panels bolted onto an existing roof. You may spend a fortune on nice clay tiles and then you cover it in this stuff. But I would like to see something more on the right where your roof effectively is the array, and it provides the full structure too. So maybe we start to see that coming through the market. One hopes we will. And lastly, I think perhaps even further forward, we'll start to see far more sophistication within the dwelling to make all these systems complement one another and ensure that we are delivering on the targets that have been set for us. So you'll start to see control systems that learn how you behave. You're already beginning to see this. Nest is an example, for example. Google bought that company for whatever it was. They'll cover all of the systems within the house, not just, say, your electricity generation, but all of the things. And it will even possibly give you the smart travel choices from your dwelling to wherever you might want to go and so on. And dare I say it, your fridge might start ordering your food too. The other thing that you might want to think about too is that we'll probably have some form of energy storage coming through, so you'll need to find space for that. The Germans are already looking at this in a big way. And the storage facility will not only capture your generation that you're going to be producing, but it will also effectively sell that excess generation at the optimum time, so that we will effectively seamlessly integrate with a smart grid system. So it helps the grid because it reduces peak demands, but it also allows you to maximize value by selling it at the point when electricity is most valued. So that's what your storage systems will begin to do. And the Germans are already doing that because their government incentives are forcing, well, not forcing them, incentivizing them to do it. And lastly, I guess some images of perhaps what a zero carbon home might look like going forward. These are some examples of people who've, some of them are CGIs, so they're ambitions for zero carbon, others are real projects. And I'll leave that with you and wait to hear your questions. Thanks.
Thanks for that, Kirk, rather. Beg your pardon, sorry. Okay, so we've had plenty of questions from you guys over the past 45 minutes, so I think without further ado we'll get to answering them. One question that's, one sort of theme of the questions we have reflects our last poll question actually. I've got a question here from Phil Brown. As the Part L 2013 changes only came into effect in 2014, does this indicate that we are unlikely to see the next changes, nearly zero carbon, in 2016? I think many of our speakers here have been in and out of the halls of Westminster before now, so if I could ask one of you to kick us off and weigh in on that. Do we think the changes to zero carbon in 2016 are realistic and actually going to happen? Tassos?
Yes, hello, and I'll pick this one up. The target was always to have zero carbon houses from 2016. Even if the changes came a little bit later in Part L 2013, that doesn't mean that this target will not be met, or that we don't have to actually try to introduce these regulations in 2016. Even though it doesn't allow a lot of time to the industry to adapt and to adjust, it doesn't mean that we will not have time after these regulations come into force to actually acknowledge their impact and understand them a little bit better. So I don't see any reason why we shouldn't remain optimistic about these changes in Part L 2016 and why this target cannot be met.
Does anyone else want to weigh in on that? No? No? Okay. Okay, well, let's move on to our next question. We've had a question in from Phil Mutton. Does this mean, as in the changes to Part L, does this mean there will be smaller window openings unless one can afford triple glazing, therefore less natural light and less innovative architecture? Richard, I believe you may be well placed to weigh in on that.
Yeah, see, I'm not sure whether this comes from, this question came in when I was talking about the openings, comparing the thermal bridging to, obviously, an opening in the wall. But the actual recipe assumes a U-value of 1.4, which is not triple glazing. So as long as you're not going over the 25% of the floor area, then it doesn't restrict your ability to use windows. The thing you do need to bear in mind when you're looking at windows is that it's actually the G value of the window that's really important as well, which is the amount of solar gain effectively through that window. So see, it's not just about the U value, so you can have a lower U value window that actually is performing worse because the G value, the amount of heat you're getting from the sun, is lower. So see, it shouldn't force you down a route of triple glazing or smaller windows. That's certainly not what we're expecting to see for 2013.
I'm going to ask Stephen if you could just come in on that as well.
There's a couple of points I'd like to add to that. And firstly, it's the importance of good information from product and system manufacturers, and people understand the information they're given that enables them to properly enter details in SAP, and then for people building the buildings to respect the specifications and not make last-minute changes to the specifications, so that by people who don't understand the implications of the specifications are adopted. So that's the first thing. I think the second thing to add again is just to re-emphasise is that window, the recipe that calculates your SAP, your target energy emission rate, the TER, does take into consideration the window area. So it will calculate your target based on 25%, or if you put a bigger area in, it's at least at 20%. So, you can, most developer houses at the moment probably have a window area of less than 25%. So the options are there.
Just a quick one, really, in response to Stephen. The calculation now is based on your actual window area. The point about having smaller windows, I guess it's a probably valid question to ask. I would be more concerned about overheating now, given that we're building to very high insulation standards and airtightness standards particularly. That said, there's nothing to stop you using the tools in your box to address those overheating concerns using appropriate ventilation. Some thermal mass where you need to use it. Clearly there is a conflict between thermal mass and achieving high fabric standards, albeit it's another compromise of many that we're all used to, I suppose. And of course, shading where it makes sense to use shading. So it can be dealt with. That said, I'm not sure much design is actually factoring that in early enough at this point in time.
Okay, thanks for that. I hope that's answered that question. Just to move on to another one, we had a question in from Sharon Askew. Do Knauf have a suite of thermal bridging details available I can refer to as a SAP assessor, or do I have to consult Knauf Technical on an individual job basis? I thought you could probably clear that up for us, Simon.
We have got a series of thermal bridging details for standardised construction, but obviously they may not be appropriate to the details that individual designers might choose. And the thermal bridging calculation is very sensitive to small changes that look insignificant but actually make a significant difference. So people would need to have adopted the design detail and then accept it and say that they're going to use it before those details can be implemented.
Okay, thanks for clearing that up for us. Just move on to another question. This is one that a similar kind of point was raised by a couple of people. This is from Sam Vazy. Carbon offsetting is ridiculous. We should be aiming to build efficiently, not offset. May as well buy a portion of the rainforest and build terribly. It's a ridiculous notion to adopt. Strong comments there. I think Tassos would have a response to that.
Yes. So when we discuss about carbon offsetting, you can only access this solution after specific requirements have been fulfilled on site, which means that you will still have to produce a very efficient structure and to use on-site low and zero carbon technologies and reduce your carbon emissions to an acceptable level, which is quite low, I can assure you about this. The reason that we have introduced allowable solutions as a mechanism to offset some of the carbon is because some of the solutions on the market when it comes to bigger carbon reduction projects can only be unlocked with a big upfront investment. And some of the solutions that you have on the market at the moment to build to zero carbon, all on-site solutions actually are not as cost effective. So when we discuss about sustainability and energy efficiency and energy efficient economy, we have cost optimal and cost efficiency as main parameters as well. So as systems develop, you have to actually move towards these more efficient systems. But again, as I said before, this carbon offsetting mechanism cannot be accessed before you have achieved, according to the proposed zero carbon definition, a specific performance on site, which, believe me, it's quite tight. And with the amount that you can collect from the allowable sources, you can unlock bigger opportunities that you wouldn't be able cost effectively or efficiently to implement on your site. So this is the only reason.
Kirk? Yes, worth adding that the UK GBC did a very good report very early on when this concept was proposed that showed that a large number of building types cannot do it all on site. So we needed a mechanism that allowed you to effectively abate the carbon some other way. The issue here is not so much the fact that an offset exists, it's the credibility of that offset mechanism. And that's where all the discussion is at the moment, including Treasury's involvement in it and its use as a possible land tax. So this is an important area that's got to get right. We're already being asked to do an awful lot as new build developers to add to a very large cost base by imposing a very large land tax. It may not be the appropriate route. So I think we've got to try and get this one sorted, really.
Okay, and I think Richard's just got a couple of comments to add to that.
Yeah, I mean, I'd just like to add to that is that when you look at sustainability as a broader field, the grand scheme of things, is it worth a builder spending a significant portion of money for what is quite a small increase to get to that zero carbon target, or is it better for them to actually pay money into a pot that can have a bigger effect elsewhere, such as obviously improvements on existing stock, things like that. So obviously in terms of actual reducing the amount of carbon housing produces, you can spend that money better elsewhere than spending it all on making sure that one new build house reaches the zero carbon thing. So that's the thing you need to remember with that.
Okay, let's move on to a slightly similar related kind of question from David Marks. Isn't zero carbon very much theoretical? And even if it is achieved, what happens to a zero carbon dwelling that has PVs and solar thermal panels, then a 10 to 15 story building is built in front of it? It is no longer zero carbon. Stephen?
I think, answering the last part of that question, I think we have to say that we have to rely on the planning, the much maligned planning process to stop the the construction of buildings that are shading PV and solar thermal. I might be being ridiculously optimistic there, but I don't see what we can do about that. And I think the question isn't zero carbon very much theoretical. I think is kind of answered by the fact that the definition of zero carbon in houses changed. The official government and Treasury definition of zero carbon in houses changed about 3 or 4 times since it was first announced in about 2008, I think. So I think the secret for me is that we have to build efficient dwellings that perform to expectation, and we have to be ambitious in our target for fabric thermal energy efficiency. It's been demonstrated, if you're not bothered about energy, zero carbon, it has been demonstrated that the cost optimal thicknesses of insulation, or should I say fabric thermal performance, are much higher than we are currently specifying in the UK. And right across Europe. That's the only country in Europe that is building optimal thicknesses of insulation in Sweden. And so consequently, even if zero carbon is theoretical, we still have to improve both the delivery and our ambition for new dwellings.
Okay. I'd like to get the panel's view on another question before we, because we're getting close to time here. But Neil Swift said, "What's the panel's view on passive house? Tried and tested to work," he said. I can see Kirk has said that he agrees with that, but I'd be interested to know what some of our other panelists think as well. Tassos?
Yes, hello, Ben. Passive house is a principle, is a methodology to construct a house that it is very efficient. The building regulations and the targets are technologically neutral, and this is the approach we use in the proposed definition as well. So if you were to use the passive house standards, or to build to a passive house standard that can actually comply with the zero carbon definition as it was proposed, then fair enough. If you use another methodology, again, it's an open market. There is a lot of competition between products and services, and the hub is not supporting exclusively one technology or the others. Their solutions will have to be easy to access from all the different types and to be able to comply with the definition. That said, passive house is just a nice product, I guess.
If we could just hear from Richard on that one.
Yeah, I mean, obviously with passive house, it's a very good standard, obviously in terms of fabric performance of a dwelling. But obviously what we do need to remember is the first question: could we build the required 200 to 250,000 houses a year with the passive house standard? And the other thing to bear in mind is that it is a voluntary standard, so it's a very harsh standard, but ultimately if you don't comply with it, other than some maybe some marketing issues if you've marketed it as a passive house, you just don't achieve passive house. If you set that kind of standard that's that difficult for building regulations and you don't hit it, it's a much more difficult question to ask. Obviously passive house is voluntary, you don't have to hit it. If you set that as a standard that all buildings have to get to, being as difficult as it is, it would obviously have a big impact on actual compliance, and that would obviously be a significant concern.
Thanks. If we can just hear from Stephen on that, and then we'll wrap up.
I think what's very interesting in passive house is the two aspects to it. There's the performance ambition that it sets, and there's also the process control that it adopts. And I think we've got some lessons to learn perhaps from the process control, because they treat information is treated much more with much greater respect, and there is a much higher degree of checking of construction in the passive house process, I believe, and I think that's probably an interesting lesson for us.
Okay, thanks for that, Stephen. We've pretty much got to the end of our webinar here today. All that's left for me to do is to thank you all for tuning in and listening in, and for all your great contributions on the comments. I'm sorry if we didn't get to your particular question today. I would just like to thank our speakers, Richard, Stephen, Tassos and Kirk, for participating. As I said, all these slides will be available later. A final thank you goes to our sponsors, Knauf Insulation, and I hope you enjoyed the webinar. Thanks very much.